Okay, so just a quick video. I've got one of these Axis network cameras, and they're really good. This one's a 216 MFD HD network camera, all supplied with power over Ethernet connections, etc. And one of the problems I've experienced is, as you can see now, although it's a really good camera during the day, at night it's not great, and there's not a lot of light in this street. So what I'm thinking about doing is putting a floodlight in my front garden, so I can brighten everything up and see a bit better. But what I don't want to do is to have the thing on all the time, because it's going to be wasteful. It's also going to annoy the neighbours. So I'm going to have one with a PIR in it, which switches on automatically, lights up the front garden as people walk through. But one of the features this camera has is it also has the ability, I don't know if you can see here, it has these this output button. And what you can do is you can click on this button here, and you can click there and click there, and that will turn something on or off. It has a switched output. It's only just open collector, but you can turn things on and off. So I thought to myself, well, I want to have the best of both worlds. How can I get around this problem? So I went to the LED hut and I purchased myself a 30-watt LED light here. So what we've got, pretty straightforward, 30 watts. You've got your sort of cob 30 LEDs in there, each one 1 watt, and you've got a PIR at the bottom. And I had a look at this. I'm going to set the board apart, and what you can see in there, you've got your sensor in the middle, and you've got this here. This is an LM324 quad op amp, and I had a quick look online to see how this thing operates, and they're relatively straightforward. Quick search on the web, and I found a circuit diagram for it. I'll link it in the description. So looking on the web, found this diagram of a basic PIR sensor for a security alarm. Here you've got the sensor, and you've got an LM324 here, a couple of amplifier stages, and then this comparator, which is referenced against some of these resistors here. Following out from that, the output then goes to this transistor which switches on a relay. All I've done is stuffed in a signal between pin 10 here of one of the stages and plus. And I've gone through using a resistance box and probing the board. That's how I found it, and I've came to a conclusion with this, that the best resistor to use is 82 kilo ohms, and using an LDR as well. The reason for that is I'm making an opto-isolator, because these boards are not they're not referenced to earth particularly. They do float all over the place, as I discovered. So for safety, and also just to maintain some isolation, because I don't really want to have any dodgy voltages making its way into the webcam. I've made up this. So all this is, when it actually focuses, let's have a look. So you've got an LDR there, and an 82k resistor in series. Those two are going to go onto be connected onto the board, and they're going to go on here. So if we just flip the board over, you'll see that there's just at the top here, just point with this LED. So we've got that's essentially connected to pin 10 here, and then this up here is a plus track, which I've marked out on the board as well. Going into that opto-isolator that I've sort of hashed together, I'm just going to have an LED. So the LED is going to be shrink wrapped to this. That will be on the board. Conveniently, the Axis camera has an onboard 3.3 volt output, which you can use for stuff up to 50 milliamps, with a open collector NPN transistor, where the emitter is connected to the ground. So basically, from the camera, I'll now be able to turn the LED on and off. That will shine on the LDR, and as soon as it does that, it should then turn on the camera. Turn on the floodlight for the camera. So we'll see how this works. Okay, so that's the resistor and LDR soldered onto the board, and now I'm just going to apply some hot melt glue just to give that a little bit more mechanical sort of connection there, and then just shrink wrap everything. Okay, so here we are. So now I've just, inside that heat shrink, you've got an LED, 5mm LED, and that's just shining on the LDR. I've just wrapped everything up in some black heat shrink tubing. I've just put some Kapton tape underneath, just to protect the board, just in case there were to be any potential for shorting. I just wanted to make sure that wasn't going to happen. And then right at the very end, I've just used some hot melt glue just to secure it there. So now I'm just going to put everything back together. Okay, so I've got everything back together now, and what I've done, as you can see on the back, I've just screwed all this shell back together. I've actually run the cable which is connecting to this opto isolator. I've managed to run it through this this hinge here, and actually quite difficult to get it through this housing. It's very tight in terms of the cable space there. The cable then runs through there and just pops back out. I've drilled a 3mm hole here at the back, as small as I could get away with really, and this is now just connected up here to two crock clips which are on my power supply. I've set this up for 3 volts, so as soon as I get this orientated right, at the moment obviously it's triggering on the PIR, so I'm just going to lift this up and just prop this up on the desk, and I'll be able to move around without setting it off myself. So just go over to the supply. You should be able to see all the light coming on as I push the button anyway. So that's on now, and you can see now the light's going on as soon as I release the power. About a second delay and it goes off again. So if I leave that running, I'll just disconnect on the crock clips here. So that's it, and release. Bingo, all working. So I'm going to get that installed. I'll probably post another video with it all working with the Axis camera, and if anyone finds this useful, if you've got any other questions, do let me know in the comments. Hopefully it's going to be useful to someone that wants to have the the benefit of a PIR sensor, but also be able to remotely turn the lights on and hold them on as well. The interesting thing about this is that if you apply the power, you don't, the actual delay that you've set on these things, that there's normally a like a delay control underneath here, where you can set the time which it's on for. That doesn't make any difference, so it doesn't affect it in any way. If you've set the thing to only come on for 30 seconds, by applying the voltage to this now on this control cable, it will stay on as long as that control voltage is applied. So it's quite versatile. You could use it for a timer, you could use it for all sorts of things, but hopefully that's a benefit to someone. Anyway, thanks for watching. Stay tuned for next time.